Let us start with the last example. We have to find the Fourier series for the fx is equal to this function in the series in the range minus pi to pi. Function is e1 pi square by 12. By putting minus x on the both side, we get the same function. For the e1 function, bn is 0. Now calculate a naught by this formula 2 upon pi integration 0 to pi fx dx. Put the value of function here, taking the integration of x square and 1. We get this answer for a naught is 0. Now calculate an 2 upon pi integration 0 to pi fx dx, fx cos nx dx for the value of function fx as it is here. Now we have to use u into v rule. This is the total term arithmetic u, this is v. Therefore we have 2 upon pi u into integration of cos is this minus its derivative here, derivative of minus this bracket is derivative of this is constant, minus as it is x square derivative 2x by 4. Its integration here minus cos nx upon n, already n square, plus its derivative here. This derivative is minus 2 by 4, that is 1 by 2, and its integration here. Next term will be 0, limit 0 to pi. Okay, now put the for lower and upper limit, sign term gets cancelled. Therefore we are concentrated on this term only. Minus 3 times minus becomes minus x by 2, 2 to the 4, cos nx upon n square 0 to pi. Put the upper limit first, minus pi by 2 cos of n pi is minus 1 raised to n upon n square, minus lower limit is 0. By putting x is equal to 0, 0 into anything is 0. Therefore it becomes minus 2 gets cancelled, pi by gets cancelled, minus 1 raised to n upon n square. Therefore Fourier series is given by fx is equal to a naught by 2 plus summation over n cos nx. Put the value of a naught and an and function here, and a naught is 0, that's why it becomes only minus 1. This is an into cos nx. Take the minus outside of the summation, it is a constant. This is the answer for Fourier series. Now consider next. Find the Fourier series for the function. The function is given in the interval format, x to pi by 2 minus x. The function interval minus pi to pi in interval divided into 2, minus pi to 0 and 0 to pi. Okay. Now range is this same, minus pi to pi, and we have to prove that this sub-question. Now first let us see how to prove the function is even or odd whenever it is given in the interval format. The method is different. Now put the minus x on both sides of the equation. We get f of minus x is equal to interval, here minus x, minus become plus, here also middle x minus. Okay, whenever less than equal to signs are there, the middle term should be plus x. Therefore that multiply both the side of this inequality by minus, so that inequality becomes reverse, less than becomes greater than. And here also we get the same, pi by 2 minus x, pi by 2 plus x, or x plus pi by 2, same term we are writing, and multiply both sides by minus, we get pi greater than. By multiplying both the side by minus, inequality gets reverse, therefore it becomes minus greater than minus plus x and greater than 0. Here also 0, multiply both sides by minus, we get 0 greater than x greater than minus pi. Okay, now take this minus pi is less than x, these two are same. Okay, by we are taking this minus interval first, it is same, these two are same things. Okay, minus pi here is less than x less than 0, and for that phi value is x plus pi by 2, and here also 0 less than x less than pi. For that it is pi by 2 minus x. If you observe this and this function, these two are same function. Okay, therefore function is e1 function, because f of minus x becomes f of x. For the interval format, these are the only changes. Okay, now let for e1 term, we know bn is 0. These are the homeworks for you. bn is 0, a naught value is formula is this. By solving this, a naught becomes 0, an is formula is this. By using u into v rule, this is the homework for you. Answer is this. Therefore Fourier series is of x is this. Put the value of a naught is 0 already. An is this cosine x. Okay, take this 2 upon pi outside of the summation, call that equation number 2. By second question, put x is equal to 0 in this equation. You will get f of pi by 2 plus 2 upon pi. This is the term as it is. Cos of 0 is 1. Now expand this summation by putting n is equal to 1, 2, 3 and so on. And we know f of 0, where to put x is equal to 0. F of 0 means by putting x is equal to 0 in the original function. Original function is this. Okay. Okay. 0 is here also and here also. Wherever you put x is equal to 0, you will get the same answer, pi by 2, pi by 2. Therefore, we are taking f of 0 as pi by 2. It is not same for all the examples. In this particular example, function values is same. That's why we are taking pi by 2. And take this pi on that side, we get pi square by 4 is equal to this. 2 into this. Take this 2 common. We get, again take this 2 on this side, we get pi square by 8 is equal to this series. Okay. Let us see now next example. Find the Fourier series for the function of x is equal to this, again given in the two function cos x and minus cos x. Minus pi to 0 cos x, 0 to pi minus cos x. Now range is again same, minus pi to pi. This is the lower limit of the range, this is upper limit, minus pi to pi. We have to see whether the function is even or odd. Put the f of minus x on the both side, we get f of minus is cos of minus x minus cos of again minus x. Here again middle x is minus x. Again we know cos of minus theta is plus cos theta. The other again minus cos x. Here just multiply both sides by minus. We get plus pi greater than inequality reverse greater than or equal to this. Okay. X and greater than 0. Here also 0 greater than x greater than minus pi. Now minus pi less than x less than 0. This take this interval first. We get it is for minus cos x, and this is 0 less than x less than pi. It is for cos x. And if you observe this, take the minus common on the from the bracket. We get minus on the outside. We get cos x here, and here also minus cos x. When you observe this function is same like this. These are the two same function. It is only minus term is there. Therefore, f of minus x is minus f of x. Okay, by taking minus outside. By anyhow you if you get these adjusted terms as it is, then only we can say if x is even or odd. In anyhow it is not there, then a function is not even, not odd. Okay, odd. F of minus x is minus fx, therefore function is odd function. For odd function we know a naught is 0, a n is also 0. Therefore we have to calculate only bn. Bn formula is 2 upon pi integration 0 to pi fx sin nx dx. Put the values function. Function is divided into 2, or the first is minus pi to 0, and second function is in the interval 0 to pi. Here our integration is 0 to pi. 0 to pi function value is minus cos x only. Therefore put this value here for the function f of x is minus cos x sin nx as it is. Now take this minus outside, minus 2 by pi integration cos, take this first sin then cos x dx, because we have the formula sin a cos b. Now adjust 2 here, because or you can take 1 by 2 directly. Or you can adjust this 2 here. You don't need to try to adjust here. Okay, take this 2 inside, we get 2 sin a cos b. Formula is sin a plus b plus sin a minus b, minus 1 by pi outside as it is. Now take this x outside to the angle. Okay, this is the homework for you. Take the sine and only sign integration, that is minus cos and minus cos. Answer is this, 2n into bracket 1 plus minus 1 raised to n upon pi into 1 minus n square. Okay, this is a homework for you, and put this for bn in the formula. Fourier series you can write down here also. Fourier series is given by fx is equal to summation bn sin nx over the n 1 to infinity. Again, here n is not equal to 1. We have to calculate b1 also. Okay, calculate b1. How to calculate b1? By using this formula first. Put n is equal to 1 here on the both side. Okay, here 1 and calculate b1 by earlier example where we have calculated b1 separately, like this only. Okay, then put this value here by separating this b1 sin x, one value 1 plus summation over n is equal to 2 to infinity bn sin nx. These are the formula for fx. Okay, now these are some homeworks for you. Find Fourier series for the function of x is equal to x cube in minus pi to pi. X cube is odd function. You can calculate Fourier series for that odd function. A naught and n0, bn is this. So homework for you. Find Fourier series for the function. This function is given in the integral format. This is the range. This is the a hint for you. Function is neither odd, neither even, nor even. Therefore, you have to calculate as it is a naught, an, and bn. Okay. These are the answers. I put this value here in the function. This is homework. Now fx mod of sin x. It is given the mod format. Therefore, minus pi to pi is given. Range, it is a even function. Therefore, for even function bn is 0 for this term. Calculate an and a naught. For that, mod of sin x, take sin x, because for 0 to pi interval all x are positive, therefore it is plus sin x. Now again, this is a 0 to pi, range is 0 to pi. This is the extra example of 0 to 2 pi. Okay, it is not minus pi to pi interval. This is 0 to pi interval. Function is given in the interval format only. So homework for you. Fx is equal to x plus x square minus pi to pi range, and f of minus x is this, and function is neither odd nor even. You have to calculate all the three functions, a naught, an, and bn. You will get this answer. Okay, these are the answers for that. And for the function which is not neither even nor odd, like this one, and the earlier one also, this one, the Fourier series formulas, as I'll write down this as it is. Okay, these are the, or you write down this. Write down this note also. For the function neither even nor odd in this particular interval, the Fourier series is given by this, and a naught is 1 upon pi minus pi to pi f x dx. An is 1 upon pi. In regular even and odd there is 2 upon pi, but when function is not even nor odd in this particular integral, the Fourier series formulas remain same, like 0 to 2 pi interval. Only the difference is limits. There 0 to 2 pi is there, here minus pi to pi. Okay, 1 upon pi minus pi to pi f x cos n x, 1 upon pi minus pi to pi f x sin x. Okay, using these formulas, these for neither even nor odd, particular these two examples, this one and the earlier one. Okay, answers are given. Now again, this is the next example. Fx is given minus pi in the minus pi to 0, x 0 to pi. Hence prove that pi square by 8 is equal to this. This is the question. The range is minus pi to plus pi. This is an important example because in this particular example, the this function is a discontinuous function. Discontinuous function example. Okay, because function is not continuous, it is not equal to anywhere. At the common number is 0 here, and at the both the 0 point is not equal to the, that's why function is discontinuous at x is equal to 0. And we need the we don't need this discontinuity for the calculation of Fourier series. We need that discontinuity point to find out this sub question. Okay, let us start with the range minus pi to pi. Fx function is given by this. Okay, well, let us see whether the function is even and odd first. In this range, f of minus x is minus x everywhere. Now take this minus, multiply both sides, we get pi greater than x greater than 0, 0 greater than x greater than minus pi. Now take this first to this, take this interval first. Minus pi less than x less than 0 is a minus x, and 0 less than x less than pi is for minus pi. Take this minus outside, it is x, it is pi for this two integral. If you observe this interval with the given function, these are not two same examples. Therefore, the function is neither odd neither even. Fx is neither odd or even. Okay, therefore we have to calculate as it is by using these formulas the Fourier series. This is the homework for you. Okay, finding out the Fourier series is the homework because it is very easy. We have already solved so many examples. Now this is the answer for the Fourier series. This is a naught is minus pi by 2, a naught by 2, that's why minus pi by 4 is there. This is an, this is bn. Okay, this is the answer for Fourier series, called that equation number 1. This you can do. Okay, now by once we have solved the Fourier series for this function, this is a make the star to this example because this is a discontinuous function at x is equal to 2. Now to find out this sub question, we have to put x is equal to 0 in this both the side. If you put x is equal to 0 on both sides, it becomes f of 0 is equal to minus pi by 4. Sin 0 becomes 0, cos 0 becomes 1, summation over this only n. Okay, take 1 upon pi common outside of this summation. Go on putting n is equal to 1, 2, 3. We get this series. On LHS side, we get f of 0 here. Take this minus 2 outside. We get all the terms plus here. Okay, now to find f of 0, because function is a discontinuous function at x is equal to 0, how we get to know that function is discontinuous? Because x is not included here. If it is equal to there, then 0 is included in any one of the interval like earlier examples. But in this example, function is discontinuous here, it is not equal to. And if you put the 0 value in this function, because 0 is not there, we have to use another definition of discontinuous function to calculate what is the f of, if fx is discontinuous at x is equal to c, and if you want to calculate f of c, then formula for is f of c plus positive interval plus f of c negative interval, value of the function in the positive interval, value of the function at c at the negative interval, divided by 2. This is the formula for calculating f of c when function is discontinued at that particular point. What is the meaning of this? This is the positive interval, negative interval. What do you mean by positive interval, negative interval? This is the negative interval because minus pi to 0, 0 less than any number less than 0 is a negative number. This is called the negative interval, and 0 to pi is a positive interval. In this particular interval, put x is equal to c, that particular point at which we want to calculate and get the answer. We get f of c plus. In the negative interval, put that point x is equal to c in the function. We get that answer for f of c minus. Add these two and divide by 2, we get f of c, value of the function at that particular point. This is the meaning of discontinuous function at that particular point. Now what is our point here? 0. Our 0, c becomes 0 here. Therefore f of 0 formula becomes f of 0 plus f of 0 minus divided by 2. What is f of 0? F of 0 plus. In the positive interval, put the value of x is equal to 0. We get 0. Okay, plus what is f of 0 negative means? In the negative interval, put x value 0, but here no x is there, that's why this function becomes pi minus pi as it is. Divided by 2, answer is minus pi by 2. Okay, this is the theory behind discontinuous function at a particular point. If you want to calculate that point, at that point if you want to calculate the function value, we have to go through this theory, because 0 is not included in any of the interval. That's why function is discontinuous function at that particular point. So that we need this theory. Answer for f of 0 is minus pi by 2. Put this value here. We get minus pi by 2 is equal to RHS at same. Now take this minus pi by 4 here. Pi plus 5 by 4 is equal to this. Now add these two, we get this 4 and plus 2 pi, which becomes minus 2 4 minus 2 pi divided by 4 to the 8. By taking LCM, it is equal to this term. Now take this 2 to cancel, minus 2 cancel on the both side, and take the pi on that side. We get pi square by 8 is equal to this series. Okay. Now these are some homeworks. F of x is equal to 1 to interval 0 to pi minus pi to 2 pi. Range is 0 to 2 pi. Earlier examples. Okay. Prove that pi by 4 is equal to this. Hints. These are the given hints to find by finding pi of Fourier series. To find pi by 4 value, put x is equal to pi in the Fourier series. We get this answer for a Fourier series. And here, if you want to put x is equal to pi on the both side of the Fourier series, f of pi we want, and pi value is a discontinuous value here, discontinuous function at pi. For that, use this theory. F of pi is equal to f of pi plus f of pi minus divided by 2. Value of the function in the both interval of function is 1 and 2. Plus 2 divided by 2. 1 plus 2 is 3 by 2. Okay, this is the hint for this particular example. Now next is f of x is given in the 3 part. Minus 1 for minus pi to 0. 1 for 0 to 0 to pi. And directly they have given the value of the function at x is equal to 0 is 0. No need to calculate f of 0 separately by using this theory. Already given, this is the meaning of this is f of 0 is equal to 0. Where we need this information to prove this. Okay. Okay, what is the Fourier series? Answer is this. Now put x is equal to 0 on the both side. We need f of 0. F of 0 is 0. It is given in the example. Okay. To find out this integration, you don't need to write x is equal to 0. Okay, take only 2 intervals. And already this value is 0 itself. Okay, to find out this pi by 4 particular value, put x is equal to 0. For that, use this value. F of 0 is 0. Answer is this. Now these are the some examples in minus pi to pi. Now next is examples in 0 to 2c interval. We have changed the interval. And earlier we have seen 2 intervals, 0 to 2 pi and minus pi to pi, even and odd and all those things. Now we are going to see the general interval where 1 to 2, 2 to 3, such type of numbers are there apart from pi. It is first interval we are going to see 0 to 2c. Fourier series for such interval is given by fx is equal to n by 2 plus summation over n a n cos n pi x upon c plus summation over n b n sin n pi x upon c. Okay, this is our equation number 1 for particular examples, where a naught is equal to 1 by c integration 0 to 2 c f x dx, a n is equal to 1 by c 0 to 2 c f x cos n pi x by c dx, bn is equal to 1 upon c 0 to 2 c f x sin n pi x upon c. These are the particular formulas for this such type of interval, 0 to 2, 0 to 3, 0 to 4, such type of intervals where pi is not there. Now let us see the examples. In this particular example, we have to first find out c value by comparing the range only. Okay, rest of the examples is same. Now find the Fourier series for the function fx is equal to 2x minus x square in the interval 0 to 2. The range is 0 to 2, means it is a general interval, and general interval you have to use this theory. For this theory, first we have to calculate c. Compare this range with this range. 0 to c is equal to 0 to 2. Therefore, comparing the numbers, 2c is equal to 2, c is equal to 1. Therefore, put this value c is equal to 1 in every about 3 examples. We get Fourier series is given by fx is equal to a naught by c. Everywhere where is c, there is 1. Okay, cos n pi x plus summation b and sin n pi x. Call that equation number 1. A naught, this is a naught, 1 upon 1, 0 to 2c is upper limit is 1. The limit of the integrations are same as the range. Okay, everywhere fx dx. Now for this integration 0 to 2, this integration is very easy. Answer is 4 by 3. Now next an value is 1 upon 1, 0 to 2c, 0 to 2 fx cos n pi x upon c is 1 dx. Now put the value of fx, that is 2x minus x square cos n pi x dx only. Now use u into v rule, 0 to 2 as it is. U into integration of cos is cos n pi x is sin n pi x upon derivative of n pi x is n pi, minus this derivative here, 2x derivative is 2 minus 2x. This integration here, sin integration is minus cos n pi x upon n pi, already n pi is there, that's why n square pi square. Now then plus its derivative here, this derivative of bracket is minus 2 only, and its integration here, minus as it is, cos integration is sin n pi x upon n pi, already n square pi square, therefore n cube pi cube. Next will be 0 because minus 2 derivative becomes 0. Limit 0 to 2. Now put the take the first by before putting the limits, take this minus plus, this term as it is, this minus becomes plus, this term as it is plus, this again minus become plus. Okay, now we have to put 2 to the upper limit. We get minus 2 as it is by putting upper limit. 2 here, 2 square is 4, 2 into 2 4 minus 4 is 0, here it is 0. Again 2 minus 2 to the 4, 2 minus 2, 2 minus 4 is minus 2, and cos of 2 n pi upon n square pi square, minus 2 cos of 2 n pi upon n square pi square, plus 2 into sin 2 n pi upon n cube pi cube, plus 2 into sin 2 n pi upon n cube pi cube. Now minus, now lower limit 0, sin 0 is 0, again sin 0 is 0, again cos 0 is 1, this is 0, 2 upon n square pi square, 2 upon n square pi, this is a minus of lower limit minus. Okay, bracket complete, square bracket complete of the an. Now again cos of 2n pi is 1, sin 2n pi is 0. Okay, and this is minus 2 upon n square pi square, this is minus 2 upon n square pi square, both the terms are same, minus 4 upon n square pi square. Now bn, same way calculate bn, this is homework for you. Bn is 0. What is the difference between an and bn? Bn, just replace cos by sin only. Okay, you will get the answer. This is homework, which is 0. Therefore put these values in the Fourier series 1. We get fx is equal to a naught by 2, a naught is 4 by 2 into 3 is 4 by 6, plus summation, this is a an, cos n x, and bn is 0. Take this minus 4 by pi square outside. This is 2 by 3. Fx value is 2x minus x square. This is a Fourier series for the function where the interval is 0 to 2 apart from the earlier interval. This is the homework for you. Once you find out how to calculate integration, rest of the everything is same. Fx is equal to 4 minus x square in the interval 0 to 2. Interval is same. C value should be same like earlier 1. What is the homework? Answer is a0 is this, an is this, abn is this. Okay. Second, fx is equal to 2x minus x square in the interval 0 to 3. Now 0 to 2c theoretical interval should be equal to 0 to 3. 2c is equal to 3. Therefore, c is equal to 3 by 2 everywhere. Okay. This is a homework. Calculate this. A0 is 0, an is this, bn is this. This is the answer for this. C value is 3 by 2. These are the steps. Again, sub questions are also there. These are the steps. Okay, this is the answer. You can pause and see all the steps. Very easy steps are there. Okay.